Hi, good day everyone. We will be presenting the application of second order differential equation in a RLC series circuit. Our group includes HARSHINY, Hakim, Adam, SHEHRIYAR and me, REZA. Hi everyone, my name is REZA RABBI. Now I'm going to explain the introduction, which is regarding the RLC circuit and its relationship with the ordinary differential equation. So what is an RLC circuit? An RLC circuit is an electrical circuit which is consist of a resistor, capacitor and an inductance that might be connected in a series or in a parallel way. The initial conditions are given here according to the questions, and also according to the questions the values of the inductance, resistor, capacitor and the electromotive force are shown here. Here in the slide, the relationship between the ordinary differential equation and the RLC circuit is shown. So the equation we saw in the question is given here. So this equation came from Kirchhoff's voltage law, which is in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drop within the same loop, which is also equal to 0. Now the RLC circuit, according to our problem, is a series circuit. So the differential equation that governs our problem is also shown here. Thank you very much for your attention. Now our groupmate Adam will present the problem description.
Okay, thank you Reza, and now I'm Adam. I'm going to explain about the problem description. So our question are about the RLC series circuit, which consists of a resistor, capacitor, inductor and an electromotive force. So the question also given an equation which is LdI over dt plus Ri plus Q over C equals to Et, which is equation 1, when Q0 equals to Q0, I0 equals to I0. So L is the inductance in henries, R is the resistance in ohms, C is the capacitance in farad, Et is electromotive force in volt, Qt is the charge in coulomb on the capacitor at time. So we need to find the current at time if the charge on the capacitor is initially 0, which is when L equals to 10 henries, R equals to 20 ohms, C equals to 6260 farads and Et equals to 100 volts. Now based on the equation, we need to find the equation that can find the current at certain time. As the value of L, R and C, Et are given, so we can substitute the value into equation 1 and simplify the equation to the simpler form. We also need to consider the other information which state that when Q0 equals to Q0, I0 equals to I0. Then there is still given, which is we need to differentiate both sides and we will obtain a homogeneous linear second order equation. So after obtaining the homogeneous linear second order equation, we can solve and derive the new equation to find the current at t time. We also find that we can solve the equation using other methods which are non-homogeneous equation. So the more detailed method of solving using two ways in the new equation and the new equation will be further elaborated in the methodology. So I will pass to Harshini.
Thank you Adam. Hi, I'm Harshini. Now we will be looking into the methods of solving the second order differential equation for the RLC series circuit problem. Group 2 has identified two primary approaches for solving this problem. One of them is by using the solving technique of linear homogeneous second order differential equation. So before reviewing the question, let's take a look at the steps for this technique. Steps to solve homogeneous second ODE. First, the given equation must be rewritten in the form of a d square y over dx square plus b dy over dx plus cy equals to 0. If the given equation is already in the form of linear second ODE, we can proceed with the next step. Then, corresponding auxiliary equation can be derived as am square plus bm plus c equals to 0. Next, we find the roots of the auxiliary equation. We can find the general solution depending on the types of roots of the auxiliary equation. Table 1.0 can be used as reference. Finally, if there are any initial conditions provided in the question, then they can be substituted into the general solution to find the values of the constants a and b. So that is all for the common procedure to solve the linear homogeneous second order differential equation. Now let's learn what the question is asking us. So the question has provided us with an initial value problem and all the values of R, L, R, C and ET. The question is basically asking us to find an equation of I, current, in terms of time t. So let's solve it by using the previous steps as assistance. According to the question, the initial values of current and charge in the capacitor are I0 equals to 0 and Q0 equals to 0 respectively. The relation I equals to dq over dt is also provided. So we substitute the given values of L equals to 10, R is 20, C equals to 1 over 6260 and ET equals to 100 into the equation 1. The following equation will be obtained. Then by substituting t equals to 0, we can get this following equation. When t is 0, I is 0, Q is 0 and I prime will be 10. Next, we differentiate the equation 3 using the relation I equals to dq over dt and simplify it, which will yield an initial value problem. Using equation 4, an auxiliary equation is attained, which is m squared plus 2m plus 626 equals to 10. By using the quadratic formula, the roots of the auxiliary equation is calculated. As a result, complex roots of m equals to -1 plus minus 25i is achieved. Thus, a general solution has this following form. Then we differentiate equation 5 to attain this equation 6. By substituting t equals to 0 and I equals to 0 in equation 5, we can get A equals to 0. And by substituting t equals to 0 and I prime equals to 10 in equation 6, B equals to 2 over 5 is attained. Hence, A is 0, B is 0.4. And the current at any time is given by the equation IT equals to 0.4 e to the power of -t sine 25t. Here I've included a detailed solution for question 6 using method A. So that is all from me now. Next, Hakim will be presenting method B of solving question 6 by using the solving technique of non-homogeneous equation. Thank you.
Alright, thank you Harshini. Hello, my name is Amirul Hakim bin SALLEHUDIN and I will explain second method on solving this problem by using undetermined coefficient. The general step to solve the equation is quite similar to the first method. Rewrite the equation into the general form and find the general solution. The difference between first method and the second method is first method fx is 0, so it is homogeneous, while there are a function in fx in the second method. So we need to find additional general solution, that is yp. Sum up the general solution to find the yc plus yp, and then evaluate the question based on additional information given. This is our question 6. Extract the information given from our question, then we get the equation needed to be solved and additional information given. Substitute all the information into the equation and you will get this. Divide by 10 to make it a smaller value. Since the question stated that I equal to dq over dt, hence the differentiation of I is equal to d square q over dt square. Substitute into equation and we are left with equation with only term of q and t. Next step, find qc. We can divide equation into this. First half is to find qc, while the other is to find qp. Treat qc like homogeneous. M squared plus 2m plus 626 equal to 0. Find the general solution by comparing it to the table given. In this case, the roots of m is complex, so we're gonna use case 3. Then we will get the answer for the QC. Third step is to find QP. We know that fx equal to 10. Use the table to get the general solution and take the smallest r, which is 0. And we will get QP equal to A, differentiate it to get Q prime P equal to 0 and Q double prime P equal to 0. Go back to our original substituted formula and substitute the value accordingly. Do the math and you will get the QP equal to 10 over 626. Okay, now we have QC and QP. Total up those and we have total general solution. Differentiate to get Q prime T. Now, evaluate it based on additional information given. When Q equal to 0, use the right equation and you will get the value of A. Next is the tricky part here. It said I equal to 0. Question stated that I equal to dq over dt, which means it says q prime. Therefore, function of I equal to function of q prime. Use the q prime equation and then you will get the value of b. The final step is to substitute the constant a and b we get into the general solution. Question 6 want it in the term of I. Therefore, use the correct equation and substitute the constant and we get the final answer of I equal to e to the power of negative t 0.4 sin 25t. Okay, my part here is done. Next is Shehriyar with result and discussion. Thank you.
Thank you, Hakim. I am SHEHRIYAR and I will talk about results and discussions. Based on the results solution we got from both the solving methods, we will get equations it is equal to 0.4 e raised to the power minus t sine 25t. And this is the graph that we will get. This is current versus time graph. To look more into the graph and further discussions, let's move further. This is an underdamped case. Now let's look how it is an underdamped case. So this is damping factor, whereas this is resonance frequency. Now if we put in the values of R and L as the equations, as we can see, a damping factor is equals to R by 2L. If we put the values, we get damping factor to be 1, whereas the resonant frequency is equal to 1 by under root LCU, which when we put in the values, we get the resonant frequency to be 25.02. And this means that the damping factor is less than the resonant frequency. And it is by fact known that this is an underdamped case, which leads to a decaying sine graph, as we can see in the graph above. Let's look. As we can see, this is a decaying sine graph. Now let's further move on. This is a steady state. We can also see from the graph the amplitude is decreasing as the waves of the graph progress. That is why we can say the graph is in steady state. Now I will pass on to Reza for conclusion.
Thank you, Shehriyar, for your nice presentation. Now, to conclude, the ordinary differential equation describes the circuit generally, also in dynamical states and also in transient response. Of course, in steady state, the capacitor's voltage is equal to the source voltage and the current is 0. But if we want to know what happens when the source is connected, we can use this ordinary differential equation. That's all from group 1. Hope you guys enjoy it. Yeah, and thanks for sticking with us until the end.